what is accuracy and precision? Accuracy is related to how close measurements are to the true or target value, while precision is related to how close a series of measurements are to each other. It's possible to have measurements that are accurate but not precise, precise but not accurate, both accurate and precise, or neither accurate nor precise. The ideal situation is to have measurements that are both accurate and precise, indicating both correctness and consistency in the data. Our project goals is first, students should be able to define accuracy as the closeness of a measurement to the true or accepted value, and precision as the degree of consistency or repeatability in a set of measurements. Second, students should be able to distinguish between accuracy and precision, understanding that accuracy relates to correctness with respect to a reference value, while precision relates to consistency or repeatability among measurements. So, accuracy and precision are not the same thing. Accuracy true to intention, while the precision is true to itself. The first object, as you can see, first object is not accurate nor precise. Kung makikita nyo, the dots ay medyo malayo sa isa't isa and malayo rin siya sa target point. While the other one, the second one, is accurate because the dots are close to the target point. The third one is precise kasi magkadikit ang dots pero malayo siya sa target point. And the last one, accurate and precise kasi bukod sa magkadikit ang dots ay mas close rin siya sa target point. So let's have a practice question. The volume of a liquid is 26 milliliter. A student measures the volume and finds it to be 26.2 milliliter, 26.1 milliliter, 25.9 milliliter, and 26.3 milliliter in the first, second, third, and fourth trial respectively. Which of the following statement is true for his measurements? The answer is they have a good precision since kalapit lang naman sila.
We will first learn how to find the percentage of accuracy. First, we need to identify the givens, the observed value, and the accepted value. Next, we will look for the absolute error by applying the formula shown on your screens. Subtract the observed value and the accepted value. Then, change the answers to its absolute form. Or, you can try to subtract it from the bigger value to the smaller one so that you don't have to change it to its absolute form, which will be easier. After finding the absolute error, we will look for its percentage of error. Using the formula, the absolute error divided by the accepted value, and their answers will be multiplied to 100%. And lastly, we will get the percentage of accuracy by subtracting 100% from the percentage of error, which we got earlier. And that is how you find the percentage of error. And now we will learn in finding the percentage of precision. This is different from the accuracy. After the observed trials, we will then find the mean of the observed value. This is done by looking for their average. To find the number's average value, we need to add all of the observed value right here. Then, divide to the number on how many observed value there are. In this case, there are 3 observed value, so we will divide it by 3. Now, we'll find the absolute deviation. Subtract each observed value to the means. Then, add all of the answers. After that, divide the answers to how many observed value there is. This is the same as earlier. If there are 3 observed value, that is the number that you will have to divide. After finding the absolute deviation, next is the percentage of deviation. To solve for it, we will divide the absolute deviation and the means of the observed value. And the result, we will multiply it to 100%. And lastly, subtracting 100% to the percentage of deviation will give us the percentage of precision.
And now, we will try on a few examples. Number 1. Suppose you have a car that is advertised to have a fuel efficiency of 35 miles per gallon. You decide to test your car's fuel efficiency by driving it and recording the observed fuel efficiency. After a long drive, You find that your car actually achieved 33.5 miles per gallon. Calculate the percentage accuracy. So first, let's identify the given. The observed value is 33.5 miles per gallon and the accepted value is 35 miles per gallon. Now, we will look for the absolute value. Subtract the observed value to the accepted value, then change it to its absolute value. Or you can subtract the higher number to the lower one. 35 minus 33.5 equals to 1.5. So now we have our absolute error. We will use this to find the percentage of error by dividing the absolute error 1.5 to the accepted value 35, then multiply it by 100. And the answer will be 4.29. You can round off it to 2 or 3 decimal numbers. And the percentage of accuracy can be solved by subtracting 100 to the percentage of error 4.29, which gives our accuracy of 95.71%. Conclusion: the percentage of accuracy of the car's fuel efficiency observation is 95.71%.
Moving on for our next word problem involving precision. So as we had already discussed how to derive a precision and its percentage, we shall now proceed to our word problem. It is for us to practice it and relate it to a real-life situation. So our word problem for this is: a scientist is conducting an experiment to measure the density of a liquid. The accepted or true value of the liquid's density is 1.0000 or 1 gram per milliliter. The scientist performs 3 trials and obtains the following result. So the problem narrates about a scientist who's conducting an experiment involving density of a liquid. So the scientist aims from a gram per milliliter of 1, which is the accepted or true density of the liquid. So for him or her to get it, the scientist performs 3 trials and eventually obtain the following results. So for the trial 1, the scientist got 0.95 gram per milliliter. Second is 1.05 gram per milliliter. And for the final trial, he got 0.98 gram per milliliter. So, as we proceed, the first step is to get the givens or identify the givens. So first, observe error, which is the trials that the scientists obtained. So for the first observed error, we had acquired, or the scientists acquired 0.95 or 0.95. Second trial is 1.0.5 or 1.05. And for the last is 0.98 gram per milliliter. Next, the next step is to find the mean of the observed value. It is done by looking for their average, add all of the observed value, then divide the answer to the number on how many observed value there are. So, getting the mean, we have to add the 3 trials and divide it by 3, which is, it is 3 since it is also from third time trials. So, our observed error again is 0.95, 1.05, and 0.98. We have to add them, and we can derive 2.98 and then divide it by 3 since there are 3 trials, and can obtain the 0.923 as our mean. Next step is to find the absolute deviation. It is done by subtracting each observed value into the means, and it has to be absolute. Then add all of the answers, then dividing them by the sums to how many observed values there is. So it means each observed error is subtract with the mean, which is the 0.933 that we had acquired from the previous step. So subtract each, and you can get the 0.113 and then divide it by 3, which is, since we had 3 trials or observed error, and we can get the 0.038. Next step, after getting the absolute deviation, we have to get the percentage of it.
Subtract each observed value to the means, and it has to be absolute. Then add all of the answers, then divide it by the sum to how many observed value there is, which is 3. So it is done by getting the absolute deviation and its average, which is the 0.038, divided by the mean, which is the 0.993, times by 100% or 100. So divide it and then times by 100, we can get the 3.827%. For our should I say last step, we can subtract 100% to the percentage of deviation. So percentage of precision is 100% subtract by the percentage of deviation that we had acquired from the previous step, which is the 3.827. So 100 minus by 3.827. So it is equals to 96.173%. And finally, we are now in getting our final percentage of precision. The percentage of precision of these variables done on the density of liquid is 96.173, or 96.17%. So as our conclusion, we had acquired the percentage of 96.17 as for our precision. And we are done.